use it, but there's RNA ACE, which is an enzyme that chops up RNA. So if you need a sequence that's very pure for high level sequencing, you want to use RNA ACE to chop up RNA. You don't want that to contaminate your sample. PCR. So we call this sometimes TAC PCR because you're going to use the TAC polymerase. TAC stands for Thermus aquaticus, right? So this is a bacteria that lives in the deep sea vents and is not bothered by high temperatures. So when we heat up our sample to around 95 degrees, the Thermus aquaticus polymerase is not damaged and doesn't degrade from it. What we're going to do is we're going to put in our primers, which are very similar in sequence to the beginning and end of the gene that we want to amplify. Okay? So we're going to put our primers in, free nucleotides, so free A's, T's, C's, G's. That will go in the solution. We're going to use magnesium chloride to catalyze the reaction to the polymerase to add in new nucleotides. And what we're going to do is we're going to heat up our sample. We're going to go from double-stranded to two single-stranded. Primers are going to attach to either end where we want our gene of interest to be amplified. New nucleotides will be added in with the polymerase. The sample will be cooled down, and the strands will re-anneal. So we're going to have one strand, and then we're going to have two, then we're going to have four. Well, each round, we're going to double the amount of DNA that we have from the previous. So we're going to do between 30 and 45 rounds, depending on how many. Yeah. So depending on how many sequences you want, it's typically between 30 and 45. But each time you run a round of PCR, you're going to double the amount of DNA that you have, or the part that you're amplifying anyway. So the gene that you're amplifying, you're going to go from 1 to 2 to 4 to 8, 16, 32, 64, right? After 30 to 45 rounds, you're going to have tens of millions, right? So once you have that region that you're interested in amplified millions of times, you're going to run it on a gel just to make sure that you have the actual sequence that's amplified, that it even worked, right? It's possible that you had polymerase that was inactive or denatured or old. Maybe you didn't add in magnesium chloride to catalyze the reaction and actually allow for the nucleotides to be added. Maybe the PCR didn't work. The gel is going to tell you that. So you're going to run it on the gel. The gel is a matrix. So the agarose matrix will allow for smaller pieces of DNA to go to the bottom of the gel and run faster through it. And the larger pieces